think I'll show this one first. So this is what I was showing before, where the heat haze would vary with time, and I'm passing in time as an input. And we see the time goes from 0 to 1024, and it's okay up until about here. So as it's crossing from 700 to 800. And if we look at the code for that, the initial values, I have the time multiplied by 1.3 and by pi because it's an angle. And then pi times 1.3 is slightly over 8. So that's slightly over a power of 2. And then it's being multiplied by 800 right around this spot. So I think that's consistent with it going just over 1024 times 8. So it looks like my card starts to get flaky, or sine, because sine is being used to compute the curve somewhere here. Yeah, the sine of the angle. So this is basically consistent with these numbers losing precision as you go up, and it might be a couple of things. It could be that one number is on one side of the curve, the other is, like, say if you were trying to smoothly go over a hill, but you didn't have very well spaced points, so your hill might abruptly.
I don't
know if that's very clear what I'm saying. But.
Yeah, I see what you're saying, because you want a smooth transition. You want like almost a wave, I guess. But what you're saying is that because that math then begins to jump in quantity, that also visually that the image begins to jump and begins to jitter or create gaps, and that's not as smooth as you want it to be.
Right, so rather than the kind of undulating hills that sine would generate, at this point it breaks up. And we get...
Yeah, that's definitely something you have to visually represent in order to get it, right? Because as we're looking at the math, the drawing that you had before, we're like, okay, well, here's the math, here's how it grows, and then here's how it begins to grow sort of exponentially, and you're like, okay, well, I can grasp all that. But it's not until you actually see it applied to an image, that you're like, oh, okay, well, this is now creating jagged edges, and that's not my intention. So,
and this is a different one with just the color, which is also using a sine wave. And there's some, it might not show up problem on some of these, but I think here, do you see this discontinuity?
Yeah, it becomes like these green and orange stripes. Right,
and they're not as smooth.
Yeah,
and that occurs right around the same time as it did in the other picture.
Right, so they're kind of uniform all the way up to the end, and then they start to kind of break up and split. And
yeah, so the precision isn't adequate at that point.
And now, is that something that? I mean, how do you? I guess going back to the compensation question, how do you compensate for that if you know that that's coming? I mean, what do you just chop off the end of the ham there and say, okay, well, I'm not going to show you. It's not, I'm not going to show you this part, or is it? Even if your image is smaller, it's still going to continue to be a problem.
That might work. It again depends on how you're receiving your input. You might just be passing the buck on, and then you'll run into it a little bit later.
Is this a shader? I guess a generalized shader issue, or is this something specific to that occurs in Corona, or what?
It's general with floating point, but the range in a double precision is you have 2 to the 52 values that you can put in that, which is in the quadrillions. Okay. So in practice, you'd have to be doing something pretty crazy to run into it. You could increment that by 1 every second, and you would go for thousands of years. For instance, you could be doing it hundreds of times per second and do the same thing.
Right.
So you'd have to be doing massive multiplications in that. So it's not really an issue in Corona.
Well, which I am actually, and that shows clearly the problem I encountered with my water shader, because it's a value that increments every frame, and I scale it up by quite a large amount to get different sine and cosine values. And I think sine and cosine is probably the best way of showing it, because we all know what to expect. So this is really useful. But what I didn't really, I mean, you tried to explain it beforehand, I remember this, but the precision value was actually so low. I mean, that is actually quite a low maximum value, so there's no surprise. I think a lot of people can hit that value fairly easily.
Right.
So yeah, I mean, this is great stuff.
And if you don't have high precision, or you're not doing it in the vertex shader, the number 1024, if you break that up into seconds, that's only about 17 minutes. And I think if you have high precision, it's 21 hours or something like that. So
I think the thing is, we can't rely on having high precision. Is this correct? We can, graphics cards.
It's a hardware thing, yeah.
Yeah. Okay. So realistically, to be safe, we need to work to medium precision. Is that a fair comment?
If you're doing it in the vertex shader, if you can move it there, then you would have high precision available. But if you have to do it in the fragment shader, it depends if you're willing to cut off that part of the market, I guess, or otherwise you'll have to accommodate both.
Okay, I think that there are probably solutions, for most of our applications, keeping them within medium precision. But it means basically for me that if you're doing any fragment shaders or anything, it's just not even worth looking at high precision, because you can't guarantee that a device will have it. And
for instance, with the sine function, if you can't really do that in the vertex shader, because if you need to interpolate it, it's not a linear function, so it won't interpolate the way you would like it to. So you could interpolate the angle, and maybe that would work. But if you were doing significant amounts of the computation, you couldn't do that in the vertex shader because it's no longer linear. And
yeah, definitely.
There is a function available in GLES called, where is this? Okay, get shader precision format. So currently, I haven't seen that this is exposed in Corona, but it could pretty easily be done in system.getInfo, I think. And this will give you some numbers back that will tell you how much range you actually have. Like, these numbers are the minimum required to be a conforming GL implementation, but they can be higher. So Corona could pretty easily expose this, and then you could ask up front, do I have this feature? And you could use some of those things I've mentioned before, where you adapt your shader, you inject the code that's appropriate to whatever you have. But at the moment, you would have to go into native to get that. Any questions on that?